I'm Gabe. I'm a climate scientist, a professor here at Princeton in the Geosciences Department and at the Princeton Environmental Institute. I study how the ocean and atmosphere interact and how that affects the weather over land and extreme events. My father was born in Venezuela of Italian immigrants. In the 60s, came to the United States to study, and that's where he met my mother. And but when I was very young, we moved back to Venezuela, and that's where I grew up until I was 14. And I was fortunate enough, my father was working at the National Research Center there. But then the beach was close, and the beach was beautiful. Memories of childhood are snorkeling in corals that I don't know if they're still around, if they're bleached yet, or But those are these wonderful memories of being in this crystal clear, beautiful water, and so that contrast between the mountains and the ocean was very, very nice. The things I love about the ocean now are different from the things I loved about the ocean when I started. So when I started oceanography, what I knew about the ocean was the beach, and then maybe going out on a boat where you couldn't see this edge shore anymore, but it was always interacting with that sort of tiny little surface part of the ocean, swimming up to the edge of the coral reef, where then you see that dark part that sort of, it used to give me fear of heights when I would get to there snorkeling. So that was a part of the ocean that I loved, and that I still have that love for that part of the ocean. But over the years, as you study the ocean, you realize that that's just barely skimming the surface. It's an amazing system that moves energy and salt and water around. It provides habitat to great ecosystems, and it's so important in moving around carbon and other nutrients. So it then takes on a different sort of fascination. It's a much more abstract fascination because I've never touched the gyres of the ocean, right? They exist as a concept. You can see them, you can draw them, perhaps you can see evidence of them, but so it's a different connection than the one that I have and many of us have with the sort of the near shore part of the ocean. But it's great nonetheless. The reason what I do matters is both because of the intellectual pursuit, because of trying to understand how the world works, curiosity. And in addition, there is a goal to build understanding to help us make better decisions. The ocean and the atmosphere touch on our societies, touch on individuals, on ecosystems, and if we can build predictive understanding that is well-grounded, and understand the limits of it, we can hopefully come up with some better decisions in how we interact with our environment. And so there has been decades of work that shows that you can say something about the total number of hurricanes in the Atlantic the next season, just all of them, but a very small fraction of those hurricanes in the Atlantic actually come to land. And so we spent a great deal of time and effort trying to refine these predictions so we could say something about the hurricanes that come near land and threaten people, get more regional information. And those types of predictions, I think, will become much more useful over time. The atmosphere is a chaotic system. The butterfly flaps its wings, and a few days later you lose a lot of the predictability. However, you can look, if you don't concern yourself with the precise events, but rather you talk in terms of probabilities, you can look out much further than a few days. You can talk about the odds of different things happening in different places, and those odds are controlled by a number of factors. Some of them, things like El Nino, Southern Oscillation, where the tropical Pacific tends to vary over having years that are excessively warm, years that are excessively cold, and that influences the atmosphere all around the world. and that in turn will influence where hurricanes will tend to form, how frequently, and then what tracks they'll tend to have. That's just one example. There's a number of others. So when I was in graduate school, I knew exactly well who George Philander was. If you studied El Nino, you knew who George is. And remember, I had my first opportunity to see him. There was a seminar at the lab I was working at the PMEL. And I even asked a question during the seminar. I have no idea, I don't remember what the question was. It was probably a silly question, but part of it was to see if I could sort of bring myself to ask a question to George. And now I find myself on the faculty with him, which is an interesting sort of turn of history, I guess. And he's a friend. He's a great guy. My son, he's 7, and I'm not sure he fully understands what I do. He thinks it's great that I work in a building that has a dinosaur in it. He does like the weather, and they've had a section in school where they talk about the weather, and so he's been asking me a number of questions. And but what I try and tell him, that I study storms, because he remembers, or at least he remembers remembering Sandy, and so he's got a fascination with hurricanes, and so I can tell him I study hurricanes and storms, and that seems to satisfy and make him think that what I do is worthwhile. I think the main driver is always going to be curiosity, is always going to be trying to understand something, to challenge oneself, to find an answer that has been elusive before. It's not just a matter of just, there's a lot of hard work, and there's a lot of less exciting times when you're doing research, but there's this satisfaction that you recover from discovering something that you didn't know before and that you couldn't find anywhere written down. That is truly why we do most of the research we do. There's always this goal to learn, this goal to know, to discover, and I think that's a common element that we all have.